Government-mandated bans. Ever thought a simple OS update could trigger a national security crisis? In 2014, Beijing officially wiped Windows 8 from all federal systems, a move that stunned the tech industry, while users in the States adjusted to the new UI. China focused on the 100% proprietary nature of Microsoft's closed-source code. They feared that, without kernel access, they couldn't audit for backdoors, potentially compromising infrastructure across 3.7 million square miles. This ban wasn't just about software, it was a massive hardware-software pivot. To replace Windows, they accelerated NeoKylin, a Linux-based OS running on MIPS-based Lungsan architecture instead of the standard x86 chips used in the US. By 2016, over 40% of government PCs in certain provinces migrated to this new ecosystem. Tech experts were shocked to find that while the UI mimicked Windows XP, the underlying 64-bit architecture was designed to block all Western telemetry at the BIOS level. This transition involved replacing systems in thousands of offices, requiring a total redesign of local area networks, LANs, and data encryption standards. It proved that a government can effectively delete a global tech giant from its borders to ensure digital sovereignty. It's a wild example of how silicon and law collide to create a completely isolated computing environment. International sanctions. High-tech connectivity changed forever when the U.S. Department of Commerce placed Huawei on the entity list in 2019. This wasn't just a trade spat. It was a total blockade of the Android ecosystem, stripping new devices of the Google Mobile Services GMS that millions in the States rely on daily. Picture a flagship smartphone with a stunning 120Hz OLED display and 50-watt wireless charging, but suddenly unable to access the Play Store or YouTube. This geopolitical firewall forced a pivot to HarmonyOS, a microkernel-based architecture designed to unify everything from 5G routers to IoT sensors. The shift was massive. Huawei had to replace over 2 million lines of code to strip out restricted American IP while maintaining compatibility with ARM-based chipsets. By 2021, HarmonyOS had already surged to over 150 million users, yet it remained effectively banned from the U.S. consumer market due to Executive Order 13873. This created a digital schism where hardware capable of 10 Gbps throughput was rendered dark in Western networks. It's a vivid example of how international sanctions can deplatform an entire OS, regardless of its technical prowess or 5G efficiency. Even with a 64-bit multi-core setup, without the right diplomatic handshake, the software becomes a brick in certain territories. Trademark bans. Back in the early 2000s, a bold OS named Lindows attempted to bridge the gap between Linux flexibility and Windows familiarity. It was a 32-bit powerhouse for its time, designed to run Windows applications via a specialized compatibility layer. However, the tech giant in Redmond didn't find the pun funny. Microsoft launched a global legal assault, claiming the name was a direct trademark infringement that confused consumers. The litigation spanned multiple countries, with courts eventually ordering a total block on the Lindows branding. By 2004, the pressure was so intense that the company was forced to pay $20 million in a settlement just to change its name to Linspire. This wasn't just about a label. It was about protecting a multi-billion-dollar software empire from a perceived imposter. The court's decision effectively banned the OS from retail shelves in its original form, proving that, in the computing world, your brand's metadata is just as vulnerable as your source code. It's a classic story of a David versus Goliath tech battle, where the legal system acted as the ultimate system administrator, deleting a brand from the market history books, even with a user-friendly GUI and support for standard IDE drives. Lindows couldn't survive the legal firewall. Today, it remains a cautionary tale of how trademark law can terminate an OS faster than a kernel panic. EULA-based bans. Installing macOS on a custom-built PC with a liquid-cooled i9 processor might seem like a fun weekend project, but you'll hit a legal wall before the first line of code even executes. This isn't just about hardware drivers. It's a strict blockade enforced by the End User License Agreement EULA. Apple's business model is a vertical stack. meaning their 64-bit Unix-based kernel is digitally locked to recognize only specific Apple hardware identifiers. Back in 2008, a company called SciStar tried to break this monopoly by selling open computers pre-installed with OS X Leopard. They weren't just selling fast hardware, they were sparking a high-stakes war over digital property rights. The legal hammer came down hard. Apple's EULA specifically forbids installing their software on any non-Apple branded computer, effectively banning the OS from 90% of the world's PC hardware, even though the kernel could technically boot on standard X86 architectures. The court ruled that bypassing Apple's encryption to run the OS on a $600 generic PC violated the Digital Millennium Copyright Act (DMCA). This legal barrier created the Hackintosh underground, a community surviving on the fringes of legality by using custom bootloaders to spoof hardware IDs. Today, with the transition to Apple Silicon and M-series chips using unified memory architecture, the barrier has shifted from legal to physical without a specific secure enclave and ARM-based silicon. The OS is essentially blocked from even initiating the boot sequence. End-of-life EOL bans. Running an old OS in a modern office is like trying to drive a vintage car. Without brakes on a high-speed freeway, it's a massive liability. When Microsoft officially pulled the plug on Windows 7 in January 2020, the software didn't just stop getting features, it became a forbidden entity across global financial networks. Banks and hospitals operate under strict compliance standards like PCI DSS, which mandate that any system handling sensitive data must have active security patches. Using a 10-year-old OS with unpatched vulnerabilities like Eternal Blue is essentially leaving your digital vault wide open for hackers. To prevent a catastrophe, modern IT departments use network access control (NAC) systems to automatically sniff out and block any device running an EOL operating system from connecting to the company LAN. The data is terrifying in 2021. Over 15% of all successful cyber attacks targeted legacy systems that were technically banned, but still hiding on Office subnets. This forced a massive migration, with corporations spending millions of dollars to upgrade to Windows 11, just to maintain 256-bit AES encryption standards across their fleet. Modern security protocols now scan the OS version during the handshake process before granting internet access. It's a fascinating cycle where the age of the code becomes its own death warrant, causing it to be expelled from the connected world for the sake of safety. This forced evolution ensures that the digital infrastructure we rely on every day remains a moving target for cybercriminals. Malware-infected forks. The open-source nature of Android is a double-edged sword that has given rise to thousands of custom ROMs promising better performance or unique aesthetics. However, the dark side of this flexibility is the emergence of malware-laden forks that are systematically blocked by global security layers. When you install a modified OS from an unverified source, you aren't just changing your UI, you're potentially bypassing the 256-bit encryption standards that keep your mobile banking safe. These black market systems are often preloaded with sophisticated spyware designed to exfiltrate data from your 128-gigabyte storage directly to remote command and control servers. To combat this, Google Play Protect and major carriers implemented the SafetyNet Attestation API, which effectively bans these non-certified operating systems from accessing critical services. If a device fails the integrity check, it is immediately blocked from using apps like Google Pay or Netflix, rendering the high-end hardware practically useless for daily tasks. Recent data shows that over 20% of these unofficial forks contain some form of embedded Trojan, leading to a hardline blockade by mobile networks to prevent botnet propagation. This digital quarantine is essential for maintaining the health of the mobile ecosystem. It proves that while you might own the hardware, the software environment is strictly policed to ensure that a 5G-enabled device doesn't become a 24/7 surveillance tool for cybercriminals. Corporate firewall block. In the sterile environments of high-security corporate networks, some operating systems are treated like digital phantoms that must be exorcised. This is particularly true for privacy-focused platforms like TempleOS or Unix, which are designed to leave zero digital footprints. These systems route every single packet of data through the Tor network, providing layers of anonymity that make it impossible for an IT department to monitor bandwidth or enforce data loss prevention (DLP) policies. For a modern enterprise, an unmonitored 1 Gbps connection is a massive liability that could hide the theft of gigabytes of intellectual property. Most Fortune 500 companies now use advanced firewall rules that perform Deep Packet Inspection (DPI) to identify and block the specific signatures of these stealth operating systems. By detecting the unique handshake patterns of the Tor protocol, these firewalls can terminate a network session in less than 50 milliseconds, effectively banning the OS from the local area network LAN. This isn't just about preventing slacking, it's a hardline defense against insider threats and corporate espionage. Even if your laptop features a high-resolution 4K display and top-tier security chips, it will be rendered an offline brick the moment a privacy-centric OS tries to talk to the corporate gateway. It is a fascinating clash between the individual's right to total privacy and a corporation's need for total transparency. In this environment, the very features that make an OS secure for an activist make it illegal for an employee. Military-grade bans. Walking into a high-security military installation with a standard consumer-grade OS is a fast track to getting your device confiscated. In these environments, the open nature of commercial systems like Windows or Android is viewed as a massive tactical vulnerability. These platforms often contain millions of lines of non-audited code and telemetry services that ping back to commercial servers, potentially leaking the GPS coordinates of a classified facility. To prevent this, defense departments enforce a total blockade on civilian operating systems, replacing them with highly specialized, hardened kernels like Linux or proprietary real-time operating systems (RTOS). This isn't just a minor policy, it's a hardware-level lockdown where any OS lacking a Trusted Platform Module (TPM) 2.0 integration and multi-level security MLS architecture is physically barred from the network. In 2022, the shift toward zero-trust architectures meant that even a 1% deviation from military-grade encryption standards would trigger an immediate system-wide ban. These hardened systems often run on custom RISC-V or specialized ARM processors, ensuring that even if a 5G signal is present, the OS cannot initiate a handshake with unauthorized civilian towers. The technical precision focuses on air-gapped security, where the OS is prohibited from having any wireless connectivity drivers at all. By banning commercial versions, the military ensures every bit of data moving at 10 Gbps is encrypted with 256-bit keys that meet national defense standards. It's a world where the convenience of a consumer UI is sacrificed for the absolute certainty of a digital fortress. Certification blocks. In federal computing, good security isn't enough. You need the paperwork to prove it. Operating systems failing to achieve international benchmarks, like FAPS 140, too, are effectively banned from handling sensitive government data. This certification is a rigorous technical audit of cryptographic modules. If a system's 256-bit AES encryption hasn't been validated by NIST, it is legally blocked from agencies like the FBI or the Department of Energy. While most modern Linux and Windows versions have FIPS mode, any OS straying from these validated paths is immediately flagged. The stakes are massive. Billions in government contracts depend on these certifications, and a single unpatched vulnerability in the kernel's random number generator can lead to nationwide decertification. By 2024, the bar was raised to FIPS 140, 3 requiring more hardware-based entropy and protection against side-channel attacks at the 7 nanometers chip level. This certification block ensures every device, from rugged tablets to high-density servers, adheres to a unified security language. It effectively cleanses the federal supply chain of risky software that might use weak 128-bit keys or unverified hashing algorithms. For a consumer, an OS might seem fine, but for a government auditor, the absence of a FIPS seal is an automatic access denied. It's a fascinating example of how bureaucratic standards dictate which lines of code are allowed to run the engines of a modern superpower. Ecosystem lockout. Digital platforms today operate like walled gardens, where the gates are guarded by proprietary APIs and service frameworks. An ecosystem lockout occurs when a dominant player strategically blocks its core services from running on a competitor's modified operating system. The most famous case involves Google's mobile services GMS, which include the Play Store, Maps, and YouTube. For an OS to legally carry these features, it must pass a rigorous compatibility test suite CTS. If a developer creates a forked version of Android that doesn't align with Google's business interests, the company can revoke the license, effectively banning the most essential apps from that platform. This isn't just a minor inconvenience. It is a total market blackout where a device with top-tier 5G connectivity and a 144Hz display becomes a digital paperweight for the average user. By withholding the GMS core, which manages everything from push notifications to 256-bit secure authentication, the dominant ecosystem can suffocate a rival OS before it even gains a 1% market share. In 2012, this tactic famously blocked Acer from launching an OS powered by Alibaba's Aliyun, proving that in the modern tech economy, the handshake between services is more powerful than the hardware itself. This blockade ensures that users stay within a specific billing and data ecosystem. It turns software compatibility into a weapon of market dominance, where open source comes with a very expensive set of strings attached, without the right digital keys. Even the most innovative OS is locked out of the global app economy. Specialized safety blocks. In the professional computing world, stability is maintained by a rigid hierarchy of user and kernel modes that prevent applications from crashing the entire system. Operating systems that intentionally bypass these safety layers, like the infamous TempleOS, face a systematic ban from any networked or corporate environment, built from scratch in a unique language called Holy C. TempleOS was a 64-bit multitasking system that functioned without memory protection or networking drivers. It allowed every process to run with ring 0 inches privileges, giving any line of code total control over the 640x480 resolution display and critical system RAM. This architectural choice turned the OS into a digital glass house, where a single software glitch could trigger a catastrophic kernel panic, while creator Terry Davis envisioned it as a divine masterpiece. The lack of an encrypted networking stack made it a primary target for external threats. The absence of basic firewall protocols and user privilege separation meant that a 1 Gbps fiber connection would compromise the entire kernel in milliseconds, leading IT auditors to blacklist such unprotected systems as critical security risks. This safety block acts as the final perimeter of our digital infrastructure, ensuring that hardware connected to the global internet is never compromised by the lack of architectural safeguards that have been industry standards since the early 1990s. As we wrap up our investigation into these forbidden operating systems, it is clear that code is never neutral. It is shaped by law, safety, and power. Your curiosity and support are what keep this channel digging deeper into the systems that run our world.